Alright, welcome. We are going to continue our lesson on solving systems by the elimination method. In the last video, we saw two examples. One where we simply just had to add straight down to eliminate one of our variables, and another where we had to change the signs of one of the equations and then just add straight down. Today we're going to look at two examples. Both are going to use the same process. I just want us to try it out twice to see how it works. We're going to use the same steps we wrote down in our last video. And our first example is going to be going on right now. We're going to take example, we looked at 2 last time, so this will be example 3. We're going to solve the system 2x plus y equals 3 and negative x plus 3y equals negative 12. And if we review the very first step for solving a system by elimination is to write so like terms are aligned, and we've already got that going on here. We do need to eliminate a variable, and there's two things that need to happen to do that. We need to have a variable in each equation that has the same number in front of it, same coefficient, but at the same time they're opposites. So we need, in fact, I'm looking here and I see a variable in each equation where they are opposites. They just don't have the same number in front of them, and that's our x term. We've got a positive 2x and a negative x. So what I'm going to do, and it's perfectly fine to do this, I'm going to multiply my entire second equation by 2. So I'm going to rewrite my first equation. We're still technically in step 1. We're going to have 2x plus y equals 3. And then I'm going to multiply each term in that second equation by 2. So if I multiply that first term by 2, I'm going to end up with a negative 2x. If I multiply the second term, 3y, by 2, I'm going to end up with a plus 6y. And if I multiply negative 12 by 2, I'm going to end up with negative 24. Now I can go on to step 2, add vertically to eliminate a variable. I'm going to eliminate my x terms. 2x minus 2x is 0. That's gone. 1y plus 6y, that is going to give us 7y equals, and negative 3 minus 24 is going to give me negative 21. In fact, before we move on, just for those of you who might still be a little confused as to what actually happened when I did step 1, I'm going to put some parentheses around that the second equation original, and I'm going to put a 2 to represent I multiplied it by 2. Now we're almost done solving for y, because step 3 we need to, well, first before we move on to step 3, we have to finish solving for y. So we're going to divide by 7, and we're going to find that y is equal to, well, negative 21 divided by 7, that's negative 3. Now we can go on to step 3. I was getting a little ahead of myself. I'm going to take that negative 3 and I'm going to plug it into one of my original equations. I'm going to actually use the first one to figure out my second variable. So I'm going to go 2x plus negative 3 is equal to 3. So we're going to solve this for x. Well, I want to get that negative 3 to the right side of my equation, so I'm going to add 3 to both sides. That will eliminate that negative 3. So I'm going to have 2x equals 6, because 3 plus 3 is 6. Then I'm going to divide both sides by 2, and we're going to find that x is equal to 3. Well, step 4, we need to write our answer as an ordered pair in xy. In step 3, we found our x was 3, and in step 2, we found our y was negative 3. So we've got our ordered pair. Let's do that. Let's do this one more time, just so we can really make sure we have a grasp of what's going on here. All right, we're going to look at example 4. We're going to solve the system where we have 7x minus 12y is equal to negative 22, and the other equation is 5x minus 8y is equal to negative 14. Now, when I look at this, I don't see any equation or any variables where in one and the other they're opposites, or even that they're the same. So we need to do some manipulating to do that. Something we can do is we could find a common multiple of one of these variable terms. And I do know 12 and 8 have a common multiple. They both go into 24. So what I'm going to do to make 12 go to 24, I need to multiply it by 2, which means I need to multiply that entire equation by 2. To make 8 go to 24, I need to multiply it by 3, which means I need to multiply that entire equation by 3. Now, before I do the multiplication, the y terms are the same as far as the sign. They're both negative. And we want one to be positive, one to be negative. So I either want to multiply the first equation not by 2, but negative 2, or I want to multiply the second equation not by 3, but by negative 3. And I'm going to do the second of that. So I'm going to multiply my entire second equation by negative 3. So let's just start. We're going to multiply everything in that first equation by 2. 7x times 2, that's going to give us 14x. 2 times negative 12y, that's going to give me minus 24y. 2 times negative 22, that's going to give me negative 44. Now let's rewrite the second equation. Negative 3 times 5x, that's going to give me negative 15x. Negative 3 times negative 8y is going to give me a plus 24y equals negative 3 times negative 14 is going to give me a positive 42. Now the reason that we multiply both of them is now our y term has the same coefficient, just opposites. We've got a positive and a negative 24, so now we can add them vertically. 14x minus 15x, that's going to give us a negative 1x, or just negative x. Our y terms, they cancel each other out, so we don't have to worry about that one. Negative 44 plus 42, that gives me negative 2. So negative x is equal to negative 2, but we want to know what does positive x equal. So we could divide or multiply both sides by negative 1, but since they're both negatives, all that really means x is going to equal 2. So we've got our x term. We're going to take that and plug it into one of our original equations, and it doesn't really matter to me which one you use. I'm going to use the second equation. So I'm going to go 5 times 2 minus 8y is equal to negative 14. Well, 5 times 2, that's 10. 10 minus 8y equals negative 14. Let's subtract 10. So we're going to have negative 8y is equal to negative 24. Then we divide by negative 8. We're going to get y is equal to, well, two negatives when we divide them makes a positive. And 24 divided by 8 is 3. So the last thing we need to do, since we found a y and we've got an x, is write our answer as an ordered pair. Our x is 2 and our y is 3. So our answer is the ordered pair 2, 3. That wraps up our lesson on solving systems by this elimination method.